You've probably seen code that works, but still puts a system at risk. It passes tests and gets deployed. It seems to work as expected, but, under the surface, it contains flaws most users never see. Insecure coding practices don't always cause immediate problems, but they do often lead to weaknesses that attackers know how to spot and exploit. These are often simple: a missed validation check or an overly trusted system, but these can be easy to miss without a prevention strategy. Secure coding means thinking about security while you're building. Let's look at 2 common habits that create risk and what to do instead. First are hard-coded credentials. During testing, it might seem harmless to drop a password or API key, a unique code used to authenticate and authorize software communication that allows software to communicate with each other directly into the code. But if that code gets pushed to a shared repository or deployed to production, those secrets go along with it. In one case, a Wi-Fi router model shipped with a hard-coded admin password in its configuration. Anyone who found the service could easily connect to the device. To avoid this problem, never store secrets in the code. Use environment variables that exist outside the code. For even better protection, use a secrets vault, like AWS Secrets Manager, a cloud-based service that stores and manages sensitive credentials, which is like a safe for your data. Rotate those credentials on a regular basis so that even if one leaks, it doesn't stay valid for long. Another problem is skipping data validation. If your system doesn't check input data properly, it might treat it as a command or pass it somewhere it doesn't belong. That can lead to serious issues like data exposure or broken functionality. We can't assume all user input will be safe. At the very least, the application should check that it matches expected formats before using it anywhere sensitive, especially when interacting with databases or other systems. Team-wide secure coding guidelines help prevent issues from the start. OWASP offers a solid starting point. It's an organization that provides best practices for preventing the most common web application security risks. You can also look at CWE, or Common Weakness Enumeration, a community-developed list of common software security flaws, for examples of flaws and how they show up in code. SEICert, a research team at Carnegie Mellon University focused on secure coding practices, publishes secure coding standards specific to languages like C++ and Java. Big tech companies build these into their workflows. Google, for example, enforces detailed code reviews, automated testing, and a security-first approach across development teams. They don't wait until the end of a project to start thinking about security. And with the right tools, you don't have to either. Static analysis tools like SonarQube and Fortify help catch security issues by looking at the code before you deploy it. Code review tools like GitHub's CodeQL can scan pull requests where someone adds code to a project and flag potential problems before they reach production. Microsoft follows this model in its security development lifecycle. It builds security checks into every phase, from design to deployment, so issues are caught early and often. Even the smallest habits can create big risks, so take a closer look at your team's coding patterns and start tightening the weak spots. The safest code is written with security in mind from the very first line.